Okay guys, this is Unit 4, Concept 3 on wavelength, frequency, and energy. Now before you start on this, you need your formula chart. Let me find mine. Okay, your green formula chart looks like this. Alright, and you also need your scientific calculator. So go ahead and go get those before you continue. Okay, so we are going to start by talking about three formulas that you have on the formula chart, okay? And they really are the first three. So let me show you what I'm talking about. Hope you can see this. They're right over here, okay? Under atomic structure on the front side, and they are right here. Those first three that are on the formula chart, okay? So we are going to start with the first one. It's called the speed of light equals frequency times wavelength, all right? So the speed of light equals frequency times wavelength, and that is c equals f lambda. The speed of light is c, frequency is f, and wavelength is lambda. Now c is a constant, and it is 3.00 times 10 to the 8th meters per second. Okay, it's a constant because we already have figured it out. Scientists have already, figured that out, so it's a number that's going to be the same all the time. Now, if you don't remember that, that's okay, because it is actually on the back of your formula chart, and it is the third number that is under constants and conversions. Okay, so if you just remember that the formulas are on the formula chart and the constants are also on the formula chart, and you don't have to remember a thing, you just need to know how to use them. Okay, alright, so we are going to fill in the formula triangle because they are very useful. So C is on the top, and F and lambda are going to be on the two bottom sections. Okay, alright, the second formula is energy equals Planck's constant times frequency. Okay, so this is the same Planck as Max Planck. Okay, energy is E, Planck's constant we use H, and the frequency is F. Okay, so it's E equals H times F. H, since it's a constant, it's going to be under the constants and conversions portion of the formula chart. Again, it's on the back. Okay. Alright, and if you look at it, it's H equals 6.63 times 10 to the negative 34, and this is joules times seconds. Okay, so let's put this into the formula triangle. E is going to be on the top, H and F are on the bottom two sections. Okay, now the J, this unit, is joules, and E, the energy, is measured in joules. Okay, so that is the unit. Okay, and finally we have a combined formula where we combine the two formula that were already talked about in the last two slides. Okay, so this is energy equals Planck's constant times the speed of light over wavelength, or E equals H times C over lambda. Okay, so in this case, H and C, H times C will be on the top of the formula triangle, E and lambda are on the bottom sections. Okay, H times C can be together because those two numbers are never going to change, and anytime you multiply them together you're going to get the same answer. Okay, so it's okay to put them together in the same section. Alright, so let's look at how we are going to use these. So example number 1, calculate the wavelength in meters of a light whose frequency is 8.0 times 10 to the 15 power hertz. Alright, so the first thing that you have to figure out is what are you given and what are you trying to look for. Okay, we have wavelength, which is lambda, and frequency, which is f. Alright, so I'm going to follow the 5-step method. You should remember what the 5-step method is. Alright, so if you remember, the first step is the given, and we are given the frequency, F, equals 8.0 times 10 to the 15 power hertz. Okay, don't remember that frequency is measured in hertz. Okay, second step is the answer that I'm looking for, and the answer I'm looking for is wavelength. Now wavelength, because it is a length, it's going to be measured in meters. Okay? Alright, the third step is the part where you have to figure out which formula do I use. Which of those three should be used? Okay, the way that you figure it out is you look at those three formulas and you have to find the one that has both the given and the answer variables in it. Okay, so the one that has both f and lambda in it is the first one. Okay, the first one has both f and lambda, and it's c equals f times lambda. Okay, and usually what I would like to do is draw my triangle so that if I have to do algebra, I actually don't have to. I can just use the triangle. Okay, alright, so I am looking for lambda, so I'm going to cover up lambda. If you cover up lambda, you will see that you are actually going to use a rearranged formula, lambda equals c over f. Okay, so the fourth step really is just plugging it in. So lambda equals c, remember, is 3.00 times 10 to the 8th power meters per second. Remember, that's a constant, and you can look it up on the formula chart. Okay, and the f is given, so it's 8.0 times 10 to the 15th power hertz. Okay, now I'm going to ask you to remember how to put your scientific notation into the calculator. Remember, you don't use times 10 and you don't use the caret to raise the power. Okay, you need to use the double E or the EXP button. So it's going to be 3.00 E8 divided by 8.0 E15. Okay, and your answer is going to depend on the given, okay, or the sig figs of the answer is going to depend on your given. So you have 2 sig figs in the given, so your answer will need 2 sig figs, okay? And my calculator, oh, that's a lot of zeros that it gave me. Calculator said let's see, 7 zeros. 1, 2, 3, 4, 5, 6, 7, 3, 8. And the answer is in meters. Alright, and that's the answer. Okay, so that's number 1. Number 2, what is the energy of a quantum of light of frequency 4.31 times 10 to the 14th power hertz? Alright, let's look at what we have here. We have energy, which is E, and we also have frequency, which is F. Alright, and let's see, first step is the given, and the given is F equals 4.31 times 10 to the 14th power hertz. Okay, second step, the answer that I'm looking for is the energy. E equals joules. Okay, remember that energy is measured in joules. Alright, now the third step, go to your formula chart and you're going to look for the formula that has both F and E in it. Okay, and the one that has both F and E is E equals H times F. And we're going to write this into the formula triangle. So I'm going to put E on the top, H and F on the bottom sections. Alright, and if you cover up E, you will see that we don't need to rearrange anything. It's E equals H times F, okay? Since that is what we are looking for, don't need to rearrange anything. Alright, so the fourth step is really just plugging everything in. So E equals, now H is Planck's constant, and it's on the back of your formula chart, if you don't remember it, and is 6.63 times 10 to the negative 34 joules times seconds. Okay, joules times second is just a combined unit, so don't worry too much about where we're getting that. Okay, and then we're going to multiply that by the frequency. The frequency is 4.31 times 10 to the 14 power hertz. Now remember, this is just the given. Okay, now to figure out the answer, I'm going to use my calculator. Type in 6.63 e negative 34 times 4.31 e 14. Okay, and the answer needs to have 3 sig figs because the given has 3 sig figs. Okay, and the answer is 2.86 times 10 to the negative 19 power, and the unit is joules. Okay, that's number 2. Now let's look at number 3. A quantum of light has energy of 4.14 times 10 to the negative 19 joules. Find the wavelength of this radiation. Okay, so what do we have? We have energy, E, and we also have wavelength, lambda. Alright, so the given in this case is E, energy, equals 4.14 times 10 to the negative 19 joules. Alright, and my second step, the answer that I'm looking for is the wavelength, lambda. And remember, wavelength is measured in meters. Alright, third step. Look at the formula chart. You're going to look for the formula that has both E and lambda in it. And the formula that has both of those is E equals HC over lambda. Alright, so again, I'm going to draw the formula triangle to see if I have to rearrange anything. H times C goes on the top, E and lambda in the bottom 2 sections. Okay, we are looking for lambda, so we are going to cover up lambda. And it looks like, yes, there is a little bit of rearrangement. Lambda is actually equal to H times C over E. Okay? Alright, so now, fourth step, we're going to plug in. H is Planck's constant. You can look that up in the formula chart, and it's 6.63 times 10 to the negative 34 joules times seconds. Okay, and C is the speed of light, which you can also look up on the formula chart. It's 3.00 times 10 to the 8th power meters per second. Okay, and all of this, let's draw a big line, is divided by the energy in the given, 4.14 times 10 to the negative 19 joules. Alright, so now what you're going to do is take your calculator and put this in. 6.63 e negative 34 times 3.00 e 8. And you're going to divide by 4.14 e negative 19. Okay, now your given has 3 sig figs, so your answer should have 3 sig figs. Okay? Alright, and the answer that the calculator gave me is 0.0000048, and I have to add another 0 at the end to make it 3 sig figs. And the unit is meters.